Successful R&D everywhere really is all about innovation and taking novel ideas and putting them into practice. That's what successful R&D is. No different in agriculture. The problem in agriculture, we've got the most complex biomaterial in the world, soil. And really, I think the really successful teams who will make great gains are those that do multidisciplinary research. So it'll be less individuals doing it and more teamwork. And the multidisciplinary research will involve the usual physics, chemistry, biology, but will also involve value chain and look at agricultural economics. I think what we're great at in Australia is looking at the research that is more applied and strategic. We're not great at looking at research which is more fundamental. And it's a personal belief of mine that the great innovators will be able to look over that chasm of research that's fundamental or blue sky, also doing research which is more strategic and applied. And it should really be seamless. We've got to remember that a lot of the great ideas come at the farm, with the farmer who recognises a problem, and then the scientist tries to understand the mechanisms behind that problem, the fundamental science, for solutions. So therefore, I think that successful R&D will be multidisciplinary teams, very focused on the challenges that are out there for agriculture. When you look back at the last 5, maybe 10 years, soil biodiversity has become a key thing. And where it's done incredibly well is in the development of the technologies for that biodiversity. So we pretty much know what's out there. Like 99.8% or 99% of the soil microorganisms are non-culturable. That means we don't know what to feed them in the lab, so we can see them in the laboratory. Now it's good that we've got molecular techniques that look at operational transcription units, speciation, etc. We're very good at that now, but actually all we've done is look at the numbers and differences in soil of biology. There's very little, if any, soil biodiversity research that links into function. And we need to bridge that gap. And the reason I don't think it's worked as well as we thought it would work is because it's been driven by biologists. And going back to the first question in innovation and what that would look like, I truly believe the people doing soil biodiversity and genetics research have to become more ecologically aware of how organisms operate in a complex environment. And to do that, you have to work with the chemists, the physicists, and the agronomists. The soil biodiversity research will not take us anywhere because it's too focused on the numbers and differences in biology and not focused enough on the function. If you look at plant breeding across the world, done a tremendous job. I mean, an unrecognised tremendous job at keeping this burgeoning population fed. Not just in the yield increases they've done, but also in the quality of the food. So therefore, that's a tremendous job. That will continue in the future, but the major gains will be in the hidden part of the plant, in the root systems. I spent years digging holes in pits, trying to find roots. And that's not what you want to do, but what you need to do is look at new technologies that actually look at roots in situ, capture the metrics of those roots, the root architectures, the root length densities, etc., and then use that technology for plant breeding. So no longer will plant breeding just be about the tops and the yields. It'll be about the hidden part of the plant. Last week I was at the new neutron imaging facility called Dingo in Anstone, Sydney. And they've got a fantastic new facility. It's only been open since November last year. And we'll be using that to look at non-destructive analysis of water uptake in plants. My own personal group looks at CAT scanning, high-resolution X-rays. And I think when you look at those new technologies coming into agricultural science, you see a clearer way to actually use them to answer the challenges of the future. So in plant breeding, It'll be in root-shoot communications and root architecture. And I think that's going to be one of the key things that drives us forward. That also links into soil carbon. It also links into water usage as well, because the plant and the roots are the connection of the soil to the farmer. Soil without plants, useless, right? Absolutely useless. Soil with plants, a fantastic resource, and that's what we really have to focus on. Another area I'd focus on is, and this might seem unusual to a lot of people, but we have a great drive to look at soil moisture and mapping, and also water is a key thing, especially in the Australian landscape. But most of the time we're looking at the wrong thing about water. We're looking about the amount of water that's in the soil rather than the energy of the water. That means how much energy do we have to use and a plant use to take water out. That's called matrix potential. And we have terrible systems that look at matrix potential in the field. They're slow, they're cumbersome, and generally they're not that accurate. So I would suggest a lot of effort has to go into sensor technology in soil water that makes that we can develop a sensor that provides an accurate enough picture of the ability of a plant to take up water. Now that's a simple question but really hard, and we'll need to look at real sensor industries that are perhaps not in agriculture just now. And so that connection between the agronomist, the soil scientist and the sensor technology has to come to the fore a bit more. To do innovation in any industry, you need creative time. You need time to sit and think. And I think in today's environment, especially in the public sector environment, you have less and less time to think. We seem to spend more and more time telling the government what they should already know, basically what they employ us to do. So we're getting less time to act as scientists, and far more time seems to be in the bureaucracy. And each individual organisation doesn't help themselves in that, because the government has the rules and the guidelines, and then each individual organisation, university or DPI or CIRO, then put layers and layers of internal bureaucracy on it. Now, all that does is stop you thinking about the job you should be doing, which is being a creative scientist to help the farmers and the stakeholders of the land. And I would urge any manager that's listening to this, any manager of research groups that's listening to this, is give your people at least one day a week where they can do what they want to do. And you'll find huge gains in that. Now, universities, that's relatively simple, because individual universities are autonomous in their management, and individual schools generally have autonomy in what they do, and that gets down to individual people. As long as they cover their teaching, they should have plenty of time to sit down and think. The thought shouldn't be, let's go for that next big grant. The thought should be, I wonder what would happen if. And I would really recommend any of those listening to me to spend time answering that question. And we'll be surprised by the innovation that comes out of that, rather than the innovation that's trying to be imposed on high, which pretty much never works. If you're asking the Google guys or the Microsoft guys or the Apple guys how they started, it wasn't filling bits of paper out. It was sitting there going, this is quite fun. I wonder what happens if I do that. We as scientists should be putting that at the front of our work, not behind. It shouldn't be the last thing we do. It should be the first thing we do.